Okay, Assalamu alaikum. Okay, so I will just continue the section on chain rule, section 14.5. So let me just share the node. Okay, we explained the chain rule last time and we gave one direct example. So now I will give an indirect example, okay, which is the following example. So let W equals of S squared minus T squared, comma, T squared minus S squared. This is comma. Okay. Show that T W sub S plus S T W sub T equal to 0. Okay. طبعا here W sub S means إيش partial W partial S. Okay. And W sub T means partial W partial T. Okay. How to show this? طبعا to show this I have to find W sub S and W sub T. Okay. How to find W sub S and W sub T? I have this one. I have this function here. W equals of S squared minus T squared, comma, T squared minus S squared. Here, notice here I have f of a function, comma, function. Okay. Really, yani this is H not okay. So this is a function and a function. Usually have f of a variable and a variable. So this is H a problem. Besides, to find W sub S and W sub T, in this circle, I have to use the chain rule. And the chain rule, to apply the chain rule, I have to have intermediate variables. Here I have W, then S and T. There is no intermediate variable. So what do we do for the solution? What do we do for the solution? We introduce intermediate variables. We introduce intermediate variable. Okay. How we let W, let U equals the first function inside F, S squared minus T squared, S squared minus T squared, or let me write it X better, okay, X here, and let Y equals T squared minus S squared, okay. Then I have the following, I have W equals of X, Y, with the X equals S squared minus T squared, and Y equals T squared minus S squared. Okay. Now to find W sub S and W sub T, to find these, I can use now the chain rule. Okay. Well, how? You have the following now. Okay, you have W, it is a function of X and Y, and X is a function of S and T, and Y is a function of S and T. So now what is W sub S? W sub S. I can go from W to S through two paths, one along X and one along Y, as we did before. Okay. So now this is W sub X times X sub S plus W sub Y times Y sub S. Okay. I'm using the sub notation. Any derivative of W with respect to X times derivative of X with respect to T plus derivative of W with respect to Y times derivative of Y with respect to S. Okay. So this is actually the W sub S. Now let me compute W sub S. Okay. Now what is X sub S? I have X equals S squared minus T squared. So X sub S, the derivative of X with respect to S, I count 2S. So I will write 2S here. Okay. Plus, what about Y sub S? Again, Y sub S is minus 2S. So this is minus 2S. Okay, minus 2S. Okay. Now, what about W sub X? This one here. Okay. What is derivative of W with respect to X? I have W equals of XY. But I don't know what is the formula for F. Okay. What is the formula for F? What is the function of XY? I don't know. If I know, I can find the derivative of W with respect to X. Since there is no formula for F, I will leave W sub X as it is. Just write it as W sub X. Okay. The same thing for W sub Y. There is no formula for F, so I cannot compute the derivative of W with respect to Y. So I leave it as it is, W sub Y. So this is for W sub S. You do the same thing for W sub T, W sub T, the derivative, partial derivative of W with respect to T. Again, I can go from W to T through X and through Y. And this gives us, should be very simple, W sub X times X sub T plus W sub Y sub times Y sub T, okay. Compute, W sub X will remain as it is, X sub T minus 2T minus 2T, W sub Y as it is, Y sub T, derivative of Y with respect to T, هيكون 2T, 2T. So this is W sub S and this is W sub T. Now I substitute here, okay. This implies then, so. Now what is T? W sub S plus S W sub T, okay. This is what I want to show. You compute this one and show that it is equal to 0. So now I have W sub S and W sub T computed here, substitute here and see what you get. So this is T. What is W sub S? This is W sub S. I can write it as 2S W sub X minus 2S W sub Y, okay, plus S. What is W sub T? This is the W sub T. هتكون minus 2T W sub X plus 2T W sub Y, okay. Now multiply and simplify. So this becomes 2S T W sub X minus 2S T W sub Y plus or minus here minus 2S T W sub X plus 2S T W sub Y, okay. Notice the term with W sub X with this term, they will cancel. They are the same, so this is equal to 0. And the terms of W sub Y, these two terms here, 2ST minus 2, again equal to 0. So the whole sum will be H, will be 0. So this is H, the proof, or this is the solution of the question. So again, the main idea here, when you have W equals of a function, comma function, to apply the chain rule, you have to introduce intermediate variables. In this case, we let the first function to be X, the second function to be Y, and then we can apply the chain rule easily. Okay. This is the example for this is how to compute, how to use the chain rule. Okay. Now we go to the second point, which is not a new point. In fact, we already discussed this in the previous section for 14.3. So it is about implicit differentiation, but now by a formula. Okay. In section, we did implicit differentiation in section 14.3. Okay. So you already know. Now here you can do the same thing, but in a simpler way by a formula here. So this is good to know and to simplify or to make your work quicker when it comes to implicit differentiation. Okay. Well, let me read the how to do this. Okay. So if the function f of x, y is equal to 0 defines z implicitly as a differentiable function of x and y, then what is partial z partial x? It is minus f sub x over f sub z, provided f sub z not equal to 0, and partial z partial y equals minus f sub y over f sub z, again provided f sub z not equal to 0. Okay. F sub x means, well, you take this, you look at this as a function of 3 variables and find its derivative with respect to x. Look at it as a function of 3 variables and find its derivative with respect to z. And the same thing here, find its derivative with respect to y. Okay. So this gives you a formula, a quick formula to compute partial z, partial x. Okay. Well, I will give just the proof of the formula, then I will illustrate it with one example. Okay. So here, really the proof is an application of the chain rule. Okay. So you have the following. I have W. I will say let, okay. W equals f of x, y, z, okay. To apply, I have it f of x, y, z equal to 0. To apply the chain rule, I have to have a function. So حتكون ايش? W equals f of x, y, z, okay. Now, what is the relation between the variables here, W? I have the following, okay. I have W It is a function of three variables, x and y and z. Okay. But I also have h, z is a function of x and y. Okay. Okay. I want to differentiate with respect to x, of course. Okay. Well, I can say also x is a function of x itself. Okay, I can just say it. X is a function of x, but y is not a function of x. Y is not a function of x. Okay. Now, what I will do is the following. I am given w. I am given h. So to find partial z, partial x, let me say partial z, partial x. Okay. This is h. It is enough to find this. Finding partial z, partial y is similar. Okay. So how to find partial z, partial x? I will proceed with the implicit differentiation as in section 14.3. I will say differentiate the equation f x y z equal to 0 with respect to x, x. Okay. This means what? Okay, this means what? The following. Okay, i.e., just say i.e. you are differentiating w equal to 0. F, okay, this function is just w, so differentiate this one. Okay. No, find derivative of w with respect to x. Okay, use the chain rule. I can go from w to x, okay, through x or through z. Okay, so when you apply the chain rule, I can w sub x, or let me say partial w partial x times dx. Okay, so this is h along the first route, along the first path. Okay, so this is h. I can go from w to x through this one. So partial w partial x times dx. Okay, plus the second path, okay, which is h from w to z to x. Okay, when you apply this the chain rule of math 101, you get h plus partial w partial z times partial z partial x equals derivative of 0 is 0, so I write h 0 here. Okay. Now what is dx with respect to x? What is derivative of x with respect to x? It is 1. Okay, so as if you are just differentiating x with respect to x, هتكون h 1. Okay, now solve for partial z partial x. So this implies the following. Okay, partial w partial z times partial z partial x equals minus partial w partial x. Okay. Divide by, I need partial z partial x. This is what I need. Okay, so divide by this one. So this implies partial z partial x equals minus partial w partial x over partial w partial z. Okay, but using the notation of the subnotation. So this is w, this is h, w here. W equals of x, y, z. So what is w sub x? It is the same thing as f sub x. Okay, so this becomes f sub x minus f sub x. What is partial w partial z? Okay, it is the same as f sub z. Okay, f sub z. Okay. Of course, provided f sub z that equal to 0. Okay. So this is h. This is the proof for this is the proof of this formula. Okay. So we have the following here. Now, partial z partial x equals minus f sub x over f sub z. Notice, just to help you memorize, not zx here, هتكون x and z, just as if you go diagonally. Okay, x and z. Partial z partial w equals negative minus f sub y over f sub z. Notice z in the denominator, y in the numerator. So this is h, the rule. Before I give an example, again, in fact, we have a similar thing for Math 101, in fact. Okay, so here, in Math 101, if the equation of xy defines y equal to 0, defines y implicitly as a differentiable function of x, as a differentiable function of x, then you see dy dx equals, in fact it is similar to the above, هتكون negative comma f sub x, you go diagonally f over f sub y, okay, provided f sub y not equal to 0. This is for math 101. This is for math 101. So even the implicit differentiation in math 101 can be done by a formula, and this is the formula for it. Okay, but now, of course, we are interested more in the situation of math 3, math 201. Okay, now let me give you an example here. So example, find partial z partial x and partial z partial y if this equation defines z implicitly as a differentiable function of x and y. Okay. I will use the formula. What is the formula? This is the formula. Okay, this is h partial z over partial x equals minus f sub x over f sub z, x and z. This is the formula given in the above theorem. Now, to apply the formula, I have to know capital F. What is my capital F? What is capital F in this equation? According to the statement of the theorem, notice هنا لاحظ هنا if the equation of x, y, z equal to 0. So the formula is given in where f is given in this form. So collect all terms in one side and equate it with 0. So to find f, I have to collect all terms in one side, and I leave 0 in the other side. But to find f in our example here, هيكون just collect y cube minus 4, take it to the other side, هتكون ايش z cubed minus xy plus y squared z minus y cubed plus 4 equal to 0. So this is my capital F. So this is f of x y z equals z cubed minus xy plus y squared z minus y cubed plus 4. So this is my capital F. Now I can apply the formula here. So this equals minus negative here. Okay. What is f sub x? What is the derivative of f with respect to x? So now we are doing just natural differentiation, partial differentiation. So f sub x, I look at z and y as constants and differentiate with respect to x. So what is f sub x here? Z cubed becomes 0, minus xy with respect to x هتكون minus y, okay, plus y squared, derivative of y squared plus z with respect to x 0, the same thing for y cubed, the same thing for 4. So the derivative with respect to x is 0, over derivative of f with respect to z. So now differentiate this with respect to z. So look at xy as constant. So derivative of z cubed هتكون 3z squared, 3z squared. Derivative of xy with respect to z 0, derivative of y squared z with respect to z هتكون y squared plus y squared. Derivative of the last two terms y cubed and 4 with respect to z will be 0. So this is what you have. So this becomes y over 3 z squared plus y squared. Okay. So this is the answer. Okay. Now just as a double check, let me find partial z partial x. Okay, let me find partial z partial x using what we did in section 14.3. Yani the usual differentiation. Okay, implicit differentiation. Will we get the same thing or not? Okay, so let's see. Now, so what do I do here? Just differentiate both sides with respect to x. Okay, so here is, let me just do it here. This is section 14.3 as we did, which is the same as math 101. So I differentiate with respect to x, looking at y as a constant and z as a function of x and y. So derivative of z cubed with respect to x هيكون ايش؟ طبعا with respect to x هتكون 3z squared partial z partial x minus derivative of xy with respect to x هتكون y is constant minus y plus Derivative of y squared z with respect to x. Again, y squared is constant. This is y squared. Derivative of z. Derivative of z حتكون ايش؟ partial z partial x. Okay. Equals derivative of y cube with respect to x 0. Derivative of 4 with respect to x 0. So this is ايش؟ 0. Now I solve for partial z partial. So take minus y to the other side. You get the following. So this equals y. And for these two terms, take partial z partial x as a common factor. This is partial z partial x. What remains? 3z squared plus y squared. Okay. Divide with a حتكون partial z partial x equals y over 3z squared plus y squared. Notice it's the same thing. Okay, it is the same thing. This is partial z partial x. Okay, it is the same. You get the same form. You get the same answer. Okay, y over 3z squared plus y squared. So you can use both to find implicit differentiation. You can use either the one what we use in section 14.3 or by a formula. It is easier to find it by a formula, especially in exam, just to save time. Okay. Now for f partial z partial y, you have the same thing. Partial z partial y. The formula is minus f sub y over f sub z. It is minus. How to find f sub y? Okay. Again, you differentiate f with respect to y, looking at z and looking at x and z as constant. So z cubed with respect to y 0 minus xy with respect to y minus x y squared z with respect to y yz minus y cubed with respect to y minus 3y squared plus 4 with respect to y حتكون 0 over f sub z. It was calculated in the previous part, so this is the same thing, 3z squared plus y squared. I can multiply the negative in the numerator. حتكون x minus 2yz plus 3y squared over 3z squared plus y squared. So this is the partial z partial y. How to compute partial z partial y by a formula. Okay. This is the end of this section.